Okay, guys, I hope you can hear me. Can you hear me, guys? Hello? Hello? Guys, can you hear me? Okay, let's get started. Let's get started. We don't have much time. We are in the last session of our today's virtual lecture. So let's do the last part of the 40 minutes. So now in here, given what we have now, guys, I have explained this. Internet. I have explained this, that when we integrated this one here, we got a u, which was in terms of y, and this one gave us, of course, if you want, you can think of this as ux, but now this is just in terms of y alone, which gave us a certain a, and this was e to the minus y. And we ended up with our a. When you throw this condition here, y only, because it's in terms of y only, and we know here y is going to be initialized at 0. So u at y 0, of course, this one would give you a, but we are saying our u0 is epsilon. So we ended up with a, which is epsilon. And we have substituted the a here, and we have ended up with this step here. I hope we are right there. Okay, so this is what we've got. We are good there. Now we had not solved this one here. So what is interesting about this part here now? Maybe I need to first of all clear this, and then we move this a little bit up somewhere there, I hope. Yes. Okay. So what I was saying, that since we have already got this part here, now I want us to look at this one here. And you can see that for this, we are saying x0 is also epsilon. Why? Because now this one is going to be in terms of x only. We already know what y is, so we can substitute for y here. We can remember in this we have 3 terms. You have the x, you have the y, and you have the u. But this one is very easy because we have already got the u. The u is this one here. I hope we are together. So this u we have here, we can substitute it. This one can be substituted into that u there. I hope we are together. And if you do that, you end up with this statement. You see this implication here. I hope we are together, guys. So it is dx over u, but the u is epsilon e to the minus y plus y. So that now we can get this in terms of x and y. Remember when we dealt with the first example, remember when I started off this, I told you that this problem is a little bit unique, whereby the conversion of this one has some u in it. Yet for all the previous examples we've looked at, the u was in the last term with respect to the dependent variable. Okay. So here, since you have x, y, and u, we can substitute the u with this one here, and then we can sort of comfortably. So what do? It is just separation of variables. If you separate the variables, the thing comes out obvious. Right? It is this one here. I hope we are together there. So you integrate this, you integrate that one. But remember, when we integrate, this will be in terms of x alone. And since we have initialized the up there, you remember we talked of this one, and now we are bringing this. This will be the condition under y, and this is the condition under u, rather x. We have a condition under X, we had a condition under Y, and then the work will be to eliminate this epsilon. So since we have now this one here, the one in red here, we can now integrate this one. The integration of this one is direct. It is what you see. I can maybe clear these reds, okay? So we are now integrating this on both sides, and this will be our condition. This condition, it is derived by us. You can even change the notation. It doesn't always have to be epsilon. It can be something else. When you integrate this, that is what we are doing here. You integrate the left, you get X as a function of Y. And this is what we are trying to do here. So this other side, we have this is a dx, you integrate dx, you get X, which is that one there, and then you have the integral of this one. We are integrating with respect to Y. It comes out obviously here. This is minus epsilon e to the minus Y, which is this term here. With respect to Y, you get Y squared over 2 guys, which is this term here. Of course, there is a constant of integration, which we are calling A. I hope no one has got lost there. I hope no one has got lost here. Okay, so now what we have, this term here, I'm going to enclose it. This is what we have is now X. It is X, which is a function of Y. Are we together? Which is equal to that whole statement. Please look at what I have just written here. It is this statement here. I hope I'm with you guys. So X, which is a function of Y, is equal to minus epsilon e to the minus Y plus Y squared over 2 plus A. I have to get A. How do I get A? It is easy. I simply impose the condition, and the condition is here. When Y is 0, X of 0 is epsilon. That is what I am doing. And if you do that, the thing comes out. So this will be epsilon. Y is 0 here, you'll get minus epsilon. This will be Y is 0, you simply get that, you get A. So let's just substitute together. Y is 0 gives me epsilon. So the left here will be epsilon. Okay. Y is 0, e to the 0 is minus 1. This will be equal to minus epsilon. I hope we are together. This is Y 0 over 2 is 0 plus A. I get a plus A. Guys, I hope we are together. So it means when this goes there, I end up with my A being simply 2 epsilon. I hope we are together. Then we substitute. So when we substitute back, what do we get? We are now going to get the entire system, which is X, this system, but this time instead of this A, the A is now, this A here, guys, this A is now 2 epsilon. I hope I'm clear. So I have X, which is equal to the whole of this. And since I have this is epsilon, we can take the epsilon out. And once you take the epsilon out and the epsilon out, I can start with the 2. I get 2 minus e to the minus ey. So this term and this term, it is what you see here. Over you guys are following, I don't know. I hope you are really following. The two you see here is this 2 epsilon. So I have factored the epsilon out, which is this one here. I hope you can see my cursor. Then I have a 2, the 2 is this, but since I factored this epsilon and that epsilon, I remain with a minus e to the minus y, which is this one here. Then I bring back the y squared over 2. This term here is that term. I hope we are together there. Okay, good. Since that is the case, you've got me there. Now I have this thing here. Now, what am I looking for? I am looking for epsilon. I must eliminate the epsilon. So in here, I make epsilon the subject of this entire enclosed statement. And if I make epsilon the subject of this entire enclosed statement, I simply get this term here. This one comes from making epsilon the subject there. Anyone who is lost? Oh, you 30 years today, you are very brilliant. This is good. Huh? So now if you make epsilon the subject, just make epsilon the subject here, meaning you're going to get epsilon in terms of x and y. It will give you this one here. Now the question is, after getting this, what is the answer? The answer is very simple. Do you remember that we have this u here? Guys, I hope you still remember that we have a u here. And I told you now this u is in terms of x and y. Remember, after substituting, I wrote and I told you now our u here is in terms of x and y. So because it is now u, which is x comma y, which is equal to epsilon, this is e to the minus y, all right? Now I'm going to get this epsilon here, which is this whole statement here, and substitute it there. I hope we are together. So I'm going to get this whole thing here and I throw it here. That will give me the u. I hope we are together. So in simple terms, what am I saying? I am saying that my u is u, which is xy. Then I get this whole statement here. I throw it here and I multiply it by this. Or if you want me to simplify it for you now, I can say, I'll use black because black will blend very well with this statement. So I get this and substitute it there. It means if I call now this one a u, okay, my u here, look at that one there, u. If I call this one u, which is epsilon, I'll substitute epsilon, which is this one, and I multiply this one with the e to the minus y. And you can see when this one goes through the thing, you can simplify. Because e to the minus y, when I multiply it with, you just expand it out. This can be x e to the minus y. You have this, then you have this denominator. That would cancel with the other one. And if you now do that comfortably, you end up with the final solution, which is this term here. This is what I've been demonstrating. You end up with this one here. The enclosed term is the u we had. You can see we have brought in this term here. Maybe I have not, I needed to show it in a way that it fits on the page with where we have come from. I can put it like that. Okay, so just look at this term here. If you look at this term, guys, it is actually this term here. You realize that the e to the minus y, this one here, it is this term we have here. I hope we are together. Then the epsilon, this epsilon here, it is this term here. Then you simplify it. When you simplify, you get this one here. Okay. I think I have finished that one. And you know, once I finish one example, you do the other examples. These things, they are the ones I have been showing you. I have already explained these. I have preempted them. Solve two differential equations in terms of if possible. This is a narrative to what I have just explained. I'm not going to go into this. You will read it to just amplify what I have already explained. What is in the chart? Someone, I beg pardon on how A becomes 2 epsilon. This is Solomon is still there. I miss this man on that former WhatsApp group I had about because my network had jumped off. You man, Eguero Solomon, you it is always only your network jumping off. But since you are my already friend from the WhatsApp group that I abandoned, I will repeat for you, Mr. Eguero. If it was someone else, I would not repeat, but it is you, my Eguero, I have to repeat. Okay, Eguero, I picked the two epsilon, which you call the E in the chart. I picked it from here. I picked it from when we integrated. Okay, there we are. We integrated this. I hope you are following. Maybe now your network is not, but this man Eguero, before you talk to him, this is a man of network issues. Eguero, are you still there? Can you say yes before I answer your question? Because I may answer and again you say the network was off. Eguero, Solomon, this man is already off. Let me first leave him. You see, I was going to answer when the network has again. He's here. Yes, Eguero. Now that you are there, you can comfortably answer. So I am saying the question you have posed over the K2E, which is epsilon. We picked it from here, young man. When you integrate this term here, we got this thing here. Integrating this gave us the statement I am enclosing in black. I think you can see this. But this statement in black comes from this XY here. I hope you can see the XY here. So this thing is XY, this XY equal to that thing. It is X, X as a function of Y, which is equal to this whole thing in black. Or maybe to be more exact, I can say, I can change the enclosure. Let me change the enclosure and I say it is this thing here. I hope now you can see me there. Now we have this condition here. X 0 is epsilon. But what is 0? From the original equation there, the 0 was y. You remember we had the u of x, comma 0, which is equal to x. I am referring to this is 0. This is the y. So when we talk of x0, that is the y, which is that we substitute. So what is x0? We are saying x0 is epsilon. So this x0 becomes epsilon, which is equal to this term here. But remember, y is 0. If y is 0, e to the 0 is 1, I get a minus epsilon. This is y, which is 0 over 2 is 0, I get plus a. Then my a making the subject a becomes this one crosses this way, that is 2 epsilon. Now, Eguero, have you understood me? You can say a yes in there. Eguero. I think the network has again disappeared. This man, Eguero. Eguero, you must look for a place with a friendly network. If you ask another question and you say, okay, very well now. Good for you, Mr. Eguero. We can now continue. Okay. Hey, I thought there was another question in the chat. Wait a minute. I had seen before Eguero, there was another question. Now this one. Farankani, Isaac Antambi. I came late. Please brief me on how to get. You man, I'm not going to brief you. If you were wise, you would also have taken Eguero's method of saying the network. But if you come, you want me to repeat it for you when you came late. People have been banning data. I have refused to repeat it for you, Mr. Ntambi. I have repeated for Eguero because Eguero was on and the network had disappeared. And now, if you know you came late, the trick is you learn it right as Eguero. You also said the network had gone. And any other question that comes under the disguise of the network had gone, I will also not answer it because you will be xeroxing Eguero's approach of questioning. Yes, Enoch Nasasera. How is A to epsilon coming? I think I have also answered you. Enoch Nasasera, if you are there, you can also acknowledge if you have followed, but I think I have answered both of these guys. Okay. Because the question Nasasera was asking is the same question Eguel Solomon asked. Okay, guys, I think that is that with that particular example. We have reached the moment I like, that moment of saying, now do this one. Okay, these are just verifications. You just go, you differentiate, there is nothing interesting, you consider the linear equation, this one. These ones we looked at some examples the other time. Verify that this one is a solution. This one you can do. That one you can do. This one you can do. All of these ones are yours. Finished. Examples. These ones you remember what you did in the calculus 1. They were piecewise functions. You'll find this is a piecewise, but it is nested. There is another one in there. And this one is piecewise the overall, but you have another nested one inside there. You can do all of these ones. Go and have fun, guys. I'm also happy for you. All of these ones are finished. This is what we have just discussed. This number here. What is in the question? Test coverage, doctor. Don't worry about that test, you people. I am going to show you the coverage after finishing. The good thing I am showing you what we have finished. These people, I think they are on fire. They want to discipline my test. Who is this one? Every Nicholas. There is. I also have Nawangwe here. I did not know we have a Nawangwe. Is this Nawangwe the student, or I have the VC peeping, stalking my lecture? Nawangwe, this man in Nawangwe. I am happy to have a student who is a namesake to the VC. I hope this Nawangwe man who is my student is also as hard as the VC we have Nawangwe. This is the VC. Now you see this man, he is called Connect Chef. Some of you have bizarre names. Okay. I would love to meet this Kamani Nawangwe, who the student over is Nawangwe, who I have not picked the other name. I just want to first look at his face, and I see if the face is also tough. Okay, nice meeting you, Nawangwe. Nawangwe, I am saying we are going to discuss the test. Okay, guys, let's focus on this second example. I have enjoyed today's lecture because I am even meeting someone who has a name that there is another chat here. Okay. All right. So what I was saying, guys, we have this example. Now, this example is directly related to what we have just discussed really. But I can go through it nonetheless. Quickly, we have a few minutes, roughly 13 minutes remaining to 2. We can now go through this one. This one is exactly what we have just discussed. So I'm not going to overwrite in this one. I'm going to just re-echo the way we have just discussed the previous example. So what do we have here? We have solve quickly. You first of all do the conversion, guys. I've told you you start with the Lagrangian conversion, or rather deduction, which you're already familiar with. So if you deal with, guys, I'm going to just throw commentaries on this because we have already done this. So you have this system here, you convert it to that system there. Okay, that's why you have a dx over 2xt. A dt, there is a coefficient of 1 here. Then you have this du here over that u there. Here, the u is already on the right-hand side, so it's not negative. The other one was negative because you had to take it from this way to the other side. Okay? I think that one is clear there. So, now that I call Alex, I apologize once again. As soon as I call, I'm talking to you. The notes are actually on Mwere. I just have to make them accessible. And I apologize in the beginning. I'm going to do this after this session. So by 3, you'll be able to access the notes. Please go there as soon as the lecture ends. Let me say at 3, because I'll take a small break after the session. So by 3, the notes will be there. Okay. All right. So we have this one here, dx. We have done the conversion. So what we are doing is a du over u dt. We take this one with that one. Okay. Clear this very fast. So we are taking these two together. You take these two together. Okay. Of course, there is a u here. Then after taking these two together, you are now taking this and this. So I think you can see when you take this together, you end up with this here. Then you can, if you end up with this, you get this. But remember, we have a condition here. Y0 is x. So it means when you solve this, guys, this is in terms of t only. If you look at this one here, it is u in terms of only t. So you have a u in terms of t only, which is equal to what? Which is this term here, which is a to the e to the t, that term there, this one. Okay. So if t is 0, you will get u0, which is epsilon, which is equal to, this is 0, you get a. So your a is actually epsilon, which is this one here. That one is finished. Then after, you come, you look for the second part. The second part is now this one here. That one. We are now considering this one, which is this one here. But remember, guys, after doing it like this, I hope you don't forget this. After doing it like this here, you have x. Remember our equation. Our equation here. You have u. U is a function of x and t. Okay? So if you look at that, now you have x. When you substitute for x, x will give you this one here. Since you already have x, we can now find u. And once we find u in terms of x, we'll just make, we'll just substitute for the epsilon in the statement for u. Okay, let me clear this. So if you look at this, we have got x here, and from this, remember what we are going to look for is the epsilon, because epsilon has to be substituted back. So if you make epsilon the subject in here, making epsilon the subject from here, making epsilon the subject, you get this statement here. I hope that is also clear. Okay. Now that this is the case, but remember we already have U. We got U. U is here. We had already got our U, which was U, which is epsilon e to the t. So I'm going to get this epsilon and substitute it into that one there. This epsilon is that. That is why when I substitute, I have e to the t. The e to the t is this one. But what is epsilon? I bring the epsilon, which is x. So in simplicity, what I have now is this one here. But remember now this u is x comma t. I hope we are together, which is equal to this one. So my epsilon is x e to the minus t squared. Then I have the e to the t. This is e to the t. Okay, then we can combine these ones together. And of course, when you take, remember the bases are the same. You can combine the bases by adding the powers. This will become e to the t minus t squared. This is simplification. I need a different color. This is simplification here. The simplification of this is what you see here. I think you can see that one there. It is this one. This one comes from that. You get this t minus that t squared, and you end up with your u, x as a function, u as a function of x, and t being equal to x e to the t minus t squared. Oh, okay, that one is finished, guys. What we have is, but Alex Bukenya, there is nothing. Let me talk to Bukenya now. Bukenya asks, what are we considering when we are choosing parts to equate? There is nothing here. If you've followed, I don't know whether you joined late, Mr. Bukenya. Guys, right from the very first example, here there is nothing like choose this, choose that. First of all, you have the x over 2xt, the dt over 1. These ones have to be equated. And then you have to bring in the u because you are looking for the u. So you can take this one first. Someone, I don't remember who asked, someone was saying, and the solution is unique because we are choosing it differently. No, we are saying this is equal to this and this is equal to this. Whatever choice you make, you are going to get the same answer. What is important is get the du, because remember u is a function of x and t. Is that okay? So in any of these selections you make, a du over u must be equal to one of these. And then the other two, in terms of only x and t, you must get a solution in terms of x and t only. And this solution in terms of x and t only is what we have got here. I think you can see this one here. Okay, then you must get one in terms of u. The one we got in terms of u is this one here. Then you use this to substitute into the other one. Trust me, the solution will always be the same. I have already answered this question. Someone was saying, it means the solution is not unique. There is a student who asked that question, and I remember he commented on that statement. So, Mr. Bukenya, needless to worry, but of course, when you're making these choices, some choices will bring out the integration very fast, and the others may slow it. So there maybe you have to be a little bit logical. Can you make choices that will make the integral come out very fast? Don't make choices that will bring the integral into integrating by parts. Is that okay? I hope we are clear. Bukenya. Okay, Asimwe, it's time. Is it time? It is not time. It is time. Talk about the test. This man really wants the test. Okay, now I'm talking about the test. This is what Bukenya wants. Is it Bukenya or Asimwe? Asime wants me to talk about the test, and let me do that in the remaining 4 minutes. But before I do that, let me first, I want to clear the thing. My app is bringing the issues. Looks like, okay, my thing went off, clear there. All right, I'm going to talk about that. So what we have, we now have all of this. You can again, you do these ones. This one is the same approach, linear. You can go and solve this using the method I have discussed there. Maybe I can, this is the same thing, by the way. You can go through all of these. All of these ones are yours. All of these ones are yours. This method here, guys, for those who may not have followed, we already discussed this approach here. This approach, we discussed it last time. I need to go back. You see where we are talking of lambda, where lambda 1 eigenvalues, vectors associated with this one and this one. This approach we discussed last time, where we had the m to the power. Yes, I think it is somewhere here. Is it here? We discussed that approach here. You remember lambda 1, lambda 2, and we looked for the eigenvectors, eta 1, eta 2, and those ones we substituted. And there was another example here. We discussed eigenvalues, eigenvectors. I hope we are together. Those of you who think we are still playing around, please, you better tighten the belts. So I am talking about this one here. These ones have already been discussed. I hope we are together. You just have to bring in some small component of the is one to wind up this thing. I'll try to maybe throw just some highlight when we meet. But this one is already okay. This is part of the is one where you solve the systems of equations, but it is directly related. Not related, it is exactly what I presented last week, but it is just the nature of the solution that borrows a little bit from the is one, and you bring in those constants of integration. Okay. So regarding, so this one is all covered. I just wanted to emphasize what we have accomplished. All of this is finished, guys. I hope you are following what we have finished. More examples, quasi-linear, this one you will do by yourselves. Yeah, I think the thing is over. You can see what we are talking about here. I can throw just some few highlights on that. So, but everything here is finished. What we are going to start with is second order when we meet on Thursday next week. This one, you can leave this one. If you want, you can go. So I'm not going to think about the nonlinear equation methods. No, this one I will not talk about it. That one we can leave it. We'll just start with the second order. These ones you can leave, but please go through all the way up to here. You can go through all the way up to before what we discussed as there was something. Yes, fully nonlinear. Leave this one out, but this one you can discuss. All of these ones you do. So you go up to page 183. You see that page there? You will go up to page 183. The test will go up to where we have stopped. The test will